Hey guys, to begin, my choice of skill for my project is learning to hit a baseball. The subject in my video is Los Angeles Angels starting center fielder Mike Trout. Mike Trout is a 3-time AL MVP and an 8-time All-Star in his last 8 seasons, so because of this, I felt he was the best player to use in explaining how to hit a baseball. The first phase in hitting a baseball is the stance phase. The goal of the stance phase is to make sure the body is stable and balanced to help the batter mentally and physically prepare to hit the baseball while waiting for the pitcher to pitch it. What we are looking for in the stance phase is the back glenohumeral joint to be abducting at about 65 degrees, the lead and trail humeral ulnar joints to be slightly flexed, the lead tibial femoral joint to be flexed at about 42 degrees, and the back tibial femoral joint to be flexed at 51 degrees. We are also looking for minimal trunk rotation, if any, in this phase. Now, to look at Mike Trout's stance phase, we see that his back glenohumeral joint is abducting at about 65 degrees. We see his lead and trail humeral ulnar joints are slightly flexed. We see his lead tibial femoral joint is flexed as well, and his back tibial femoral joint is also flexed. We also see that he has very minimal or no trunk rotation at all, indicating that his stance phase is correct and setting him up for success in the future phases. The second phase of a baseball swing begins when Mike Trout's lead foot lifts up off the ground and ends when his lead foot lands back on the ground, as shown right here. The goal of this phase is for muscles to begin concentrically contracting in the torso, the back leg, and the back arm to help generate the force and velocity necessary to hit the baseball. What we are looking for in the wind-up phase is the lead humeral ulnar joint to be flexing at about 84 degrees, the back humeral ulnar joint to be flexing at about 125 degrees, the back glenohumeral joint to be abducting at about 65 degrees, and the lead tibial femoral knee joint to be flexing at 61 degrees, as well as the back tibial femoral joint to be flexing at about 56 degrees, as seen right here. And the last thing we are looking at is the trunk rotation to be a minimal at 8 degrees rotation. In the wind-up phase, as we indicated before, we can see that as his front tibial femoral joint is flexing, his back tibial femoral joint is flexing. Also, when this is occurring, we can see his lead and trail humeral ulnar joints are also flexing, and that his back glenohumeral joint is abducting away from the baseball, as we said before. We also see, as throughout the swing, as his lead tibial femoral joint is flexing to land back on the ground, as his front foot lands back on the ground, we see that the trunk is rotating as the upper body or humeral ulnar joints are pulling away from the baseball. This is what creates the 8 degree of trunk rotation previously stated before in the swing, because the trunk is being pulled in 2 different directions, away from the baseball by the upper body and towards the baseball by the lower body. This is creating the power and force necessary to hit the baseball in the next phases. The third phase of a baseball swing begins at the end of the wind-up phase. So this phase is called the early phase. This phase begins when the lead foot gets into contact with the ground and ends when the bat is perpendicular to the ground, as we see right here. The goal of this phase is to use energy generated in the preparatory phase or wind-up phase from the muscle contractions of the back leg, the torso, and the back arm to stay balanced and ready to hit the baseball at maximum velocity and force in the next phase. What we are looking for in the early phase is the lead humeral ulnar joint to be flexed at 75 degrees, the back humeral ulnar joint to be flexed at 123 degrees, the back glenohumeral joint to be abducted at about 65 degrees, the lead tibial femoral joint to be flexed at 61 degrees, the back tibial femoral joint to be flexed at 56 degrees, and the trunk rotation to be at 8 degrees, similar to the wind-up phase, because this phase is the ending of the wind-up phase. In the early phase, we can see that Mike Trout's lead humeral ulnar joint and back humeral ulnar joint are both flexing away from the baseball, so we can see that the lead humeral ulnar joint is flexing less than the back humeral ulnar joint, so it's about 75 degrees. We see that the back humeral ulnar joint is flexing more than the lead humeral ulnar joint, so it's flexing at about 123 degrees. We can see that the back glenohumeral or shoulder joint is abducting, so we can safely assume that it's about 65 degrees. We clearly see that the lead and back tibial femoral joints are both flexing, as we can see that the lead tibial femoral joint has more flexion since it's more prominent through his baseball pants, so we can safely assume that it's about 61 degrees of flexion, and that the back tibial femoral joint isn't as easily seen through his baseball pants, so we can assume that it's about 56 degrees of flexion, as stated before. We also see minimum trunk rotation at about 8 degrees, since this is the same about the same position as the wind-up phase, as it's just pretty much the ending of the wind-up phase, maybe a little bit after the ending of the wind-up phase. The fourth phase of a baseball swing is the movement or middle phase. This phase begins when the bat is perpendicular to the ground and ends when the bat is parallel to the ground. As we see right here, the bat is perpendicular to the ground right here, and then the bat is parallel to the ground right here. The goal of this phase is to align and load muscles right before bat acceleration and contact is made with the ball. What we are looking for in the middle phase is the lead tibial femoral joint flexion to trend down from 61 to 21 degrees, the back tibial femoral joint flexion to trend up from 56 to 61 degrees, the lead humeral ulnar joint flexion to trend down from 75 degrees of flexion to about or near max extension of 0 degrees, and we are also looking at the back humeral ulnar joint to trend down from 123 degrees of flexion to 0 degrees or about 0 degrees of max extension. We're also looking at the back glenohumeral joint to abduct trending downward from 65 to 35 degrees. And lastly, the trunk rotation to increase to about 21 degrees. In Mike Trout's middle phase, we can see that as right before bat and ball contact is being made, throughout the swing or throughout the advancement, we can see that his lead tibial femoral joint is decreasing in flexion as it's nearly strained out. We also see that his back tibial femoral joint is increasing the flexion as we see from here to here that it's clearly increased and going towards the baseball, therefore increasing in flexion. We also see that his lead and back humeral ulnar joints are decreasing in flexion as they're near strained out right before contact, which is right about here. We also see that the back glenohumeral joint is also decreasing in abduction as both arms or humeral ulnar joints are near max extension right before contact. And lastly, we see that the trunk rotation is a lot greater as he turns or rotates his body to about 21 degrees to hit the baseball right about here. We clearly see the trunk rotation is increasing from here to hit the baseball. The fifth phase of a baseball swing is the late phase. This phase begins when the bat is parallel to the ground and ends after the bat makes bat and ball contact, as shown right here. The goal of this phase is to align the bat on path to hit the baseball. The first thing we're going to look at in the late phase is how the lead and trail humeral ulnar joints are at near or at max extension of 0 degrees when bat and ball contact is being made. This is shown right here. As soon as bat and ball contact is being made, we can see the humeral ulnar joints of the lead and trail arm nearly or straining out fully at maximum extension of 0 degrees. Also, what we can see here is right before bat and ball contact is being made, we can see that the glenohumeral abduction is already decreasing, and as soon as bat and ball contact is being made in this phase, we can see the abduction is transitioning to adduction as Mike Trout finishes and swings through the baseball. The next body parts to be observed in this phase is the lead tibial femoral knee flexion and the back tibial femoral knee flexion. We can see that once bat and ball contact is being made, that the knee flexion of the front knee or tibial femoral joint isn't at full extension, indicating that it's near or about 21 degrees, and that the back knee flexion is almost at maximum knee flexion of about 61 degrees, because if we advance it a little bit more after bat and ball contact has been made, we can see the front knee is fully extended and the back knee is fully flexed, indicating that Mike Trout has already hit the baseball and is now on his way to finishing the swing. The last body segment to be observed in the late phase is trunk rotation. Trunk rotation decreases dramatically as bat and ball contact is made, because as you see right here, before bat and ball contact is being made, you can tell that the trunk of Mike Trout, or the stomach area of Mike Trout, has a little bit more rotation left to hit the baseball. Now, once we see him hit the baseball, we see right here that Mike Trout's trunk has fully rotated and that it's fully facing the pitcher, indicating that the trunk has no more rotation left to hit the baseball as hard as possible. Once this happens, this means the trunk is fully rotated and that the baseball has been hit at maximum velocity and power. And the final phase of a baseball swing is the follow-through phase. This phase begins after bat and ball contact has been made, and when the bottom hand closest to the knob of the bat is supinated and the top hand on the bat is pronated. Shown right here, as soon as Mike Trout makes contact with the bat and his arms are wrapping around his body to finish the swing, we see the bottom hand is supinated and the top hand is pronated. The goal of this phase is to slow down the limbs of the upper body to make sure ligaments do not tear in the humeral ulnar joints and helps prevent dislocation. What we're looking for in the follow-through phase is for the lead and trail humeral ulnar joints to increase or transition from max extension of 0 degrees to about 27 degrees of flexion to finish the swing. We see this right here. As soon as bat and ball contact has been made, they're fully extended and then they flex to finish the swing, which is right here. We also want to look at the lead tibial femoral joint as it decreases in flexion to about 15 degrees to help finish the swing, which is right there. We see the slight flexion in the front knee or front tibial femoral joint decrease slightly from here to here. Also, we want to see the back knee or tibial femoral joint increase in flexion from about 61 to 85 degrees to help finish the upper body part of the swing to help decelerate the limbs as safely as possible. Lastly, we want to look at the trunk rotation because right after bat and ball contact has been made, the trunk is now rotating. But as the arms are flying through and finishing the swing, we see the trunk is rotating again, which is about 8 degrees, which is a small amount of rotation just to help and assist the humeral ulnar joints in finishing and decelerating the swing. To conclude my video, guys, I hope you guys learned the proper joint movements and mechanics in learning how to hit a baseball at maximum force and velocity. Thank you, and I hope you enjoyed watching.